welcome to another PyData Riyadh meetup. Our team, Abdullah, Daria, Ruba, Sarah, and myself, welcome you all. We're happy that you could join us this evening. Don't forget to check out our Twitter page at PyData Riyadh for any kind of news or events held by the chapter. We have something special this evening. Our speaker is Vincent Warmerdam. Hopefully I got that right. Vincent is an AI researcher at Rasa, a startup that builds intelligent assistants, intelligent digital assistants. Vincent is the founder and previous chair of PyData Amsterdam, and he's a huge supporter of open source, as he's the co-author of multiple open source projects, including Scikit-Lego and whatlies. And last but not least, he's been on the front page of Reddit. Wow. In this talk, we'll go over how Rasa worked. We'll explore word embeddings in Arabic with whatlies, and we'll see a bulk labeling demo. Hope you all are excited as I am. Just some logistics. We'll allocate some time for questions and answers at the end of this talk. But feel free to use the chat section to drop your answers, and we'll pick them up along the way. Over to you, Vincent.
So thanks for that introduction. So what I kind of would like to do with you all today is there's a couple of demos that I think are just kind of nice. But I should admit, I'm actually not a researcher. I'm actually more of the person in the research team that helps explain what the research team is doing. I'll explain what that means, because it's kind of a role that's super new, and part of my job is to figure out what I'm supposed to do. But you have to imagine the company that I work for, Rasa, we like to make this open source product that allows anyone to build conversational agents. And that means that, you might have some new user interfaces. If part of the dream that we have is, if you're a somewhat older lady and you're not really well versed with like navigating a website, it will be just very nice if you can just ask in a natural language form, like, hey, website, can you please fetch this for me? That's kind of the thing that we like to achieve. We just want to make better, more meaningful interactions possible. And that's going to mean that I'm going to split this talk up into 3 separate segments. I'm going to first just give you a brief demo of how Rasa works, so you kind of get an idea of what kind of problem I'm trying to solve. After that, I'm going to talk a little bit about, well, I would really also like to be able to have Rasa work for, not just English languages, but a bunch of them. And, once that's done, I would like to really give you this nice little demo that shows how you might be able to do bulk labeling. And I think that's going to be pretty cool and interesting as well. Let me just check if this works. All right. So just to check real quick, are you guys also seeing this red line over here? Or you're not seeing this? You can see me doodle, I think.
You can see the doodles and the red line.
You also see the red line here. Huh. That is interesting. So I think I might be able to fix that by quitting Screen Brush. No, okay. And if I go to Google, it is also still there. I'm gonna stop sharing my screen just real quick because the red line is bothering me. And hopefully if I reshare the screen again, the red line is gone. It's kind of a strange artifact. All right, and share screen once more. Okay, I think the red line is now gone, so we can kind of just get started with this. So what is Rasa and how does it work? The idea behind a virtual assistant, if you think about what might happen, right? It's not so much a like a standard thing that you might do in scikit-learn, because if you think about what sort of problem you're trying to solve, is you kind of have a situation that's like this. You have a person, you have a person over here, and that person is trying to say, let's say, hello. And after that, you have sort of the robot, the conversational agent that's replying. So the user might say something like hi first, and then we might get a hello back. And let's say that we're talking to an assistant that can order pizzas for you. It's like Domino's Pizza or something. Then every time that a user says something, you can imagine that there's an intent behind it. The user is saying something because we would like an action to follow. So if we are building a very good assistant, we are able to sort of take this text and then classify the next action, so to say. However, the next action is actually kind of a tricky thing if you think about it. What might happen is that that while we are in this flow of, hey, can I please order a pizza, that the user then also asks, hey, are you a human? The idea being that we might start a flow for ordering a pizza here, right? So that's kind of what's happening. We might go into this funnel, but a human is always able to interrupt the funnel by either doing chit chat or that sort of thing. So on one end, we have this problem where we would really like to do this classification task well on this text. But on the other hand, predicting the next best action, sometimes we have to do more than just look back at what the user said before. If I look at this pizza example, if we ask what kind of pizza would you like, then we ask, are you a human? There's kind of two actions after each other that are supposed to follow. First, the assistant needs to be able to say, well, let's answer this question. And after that, we should look back multiple time steps to figure out what the next best action is. And this is kind of the hard part of building good assistants. On one end, we would like to be able to predict, hey, what is your intent right now? And after that, we would like to say, well, what's the next best action going to be? That's kind of to put it into sort of simpler terms, those are the two big sub-problems as far as machine learning is concerned that we're trying to deal with. So one thing that I hope, just showing this to you, in this basic conversation, is that in order to have a system that actually can do something like this, we are probably not going to have one CSV file that we can eventually give the scikit-learn, because we're doing multiple things at once. We're trying to do something with this intent over here, as well as the actions over here. So what we've done at Rasa is we've basically made this command line utility where you just give us different files and then we'll take it on from there. And what I would just like to briefly demo is what such a project might look like and what sort of files you can expect, so you kind of have a feeling of what it can be like if you were to train your own virtual assistant. And what I'm doing now is I'm just running the assistant locally on my laptop. You can install everything by running pip install Rasa. And what I've got here is just the hello world its project from Rasa itself. If there are any questions actually right now, I could answer a few. I don't know if there are questions. So I do see some stuff in the chat. Oh, it's about being recorded. Okay, that's fine. So what I've got here is a Rasa project. And in the Rasa project, there's basically a couple of files that really, really matter. The first file that really, really matters is this NLU.yaml file. And it's a YAML file where we have examples for every single intent. So I'll just zoom in a bit just to make sure it fits nicely on the screen. But let's say an intent that the assistant might have is to say hello. Like you want to do a greeting of some sort. And what we can then do is we can say, well, if you want to go and do greeting, then here we've got a couple of examples. These are all different ways of saying hello, so to say. And if we scroll down, then we have something similar, namely all sorts of different ways of saying goodbye. And one thing I'd like to point out is that you can see that these are just examples that you could have typed. And there's all sorts of spelling errors that we have in here, which is quite common if you're building an assistant. And we also have got one here for saying affirm, for someone wants to say yes. We also have one for saying no. There's a couple of examples we've got here. And then, we've also got a different intent. You can say that you're doing well. And what I'm hoping that you might be able to realize at this phase is that it's nice to have all of these examples, but given that we have a couple of these intents with examples, we might be able to use them as Lego bricks. I actually don't, is Lego a popular toy in the, I don't know if that's actually something that's common. Just figured I'd check.
No, I guess people here.
If I say Lego, people know what I mean.
Yeah.
Okay.
Yeah.
I just want to make sure. Because the thing is, like, having something as a Lego brick is kind of nice, because what we can do now using these intents is we can kind of use it as a Lego brick to construct how a story might go. So we can have this other training file where we say something like, I don't know exactly how every conversation is going to go, but I can come up with a couple of examples of how they usually should go. And we might have a conversation here. That's what this story is all about. Like, where the user starts by saying hello, and then the action that our assistant should make is we should say hello back. And then if that is followed by the intent, hey, I'm doing great, well, then we should utter happy. So we can map these intents to actions by putting them in a story that demonstrates how a conversation might go. This is kind of like the flow, so to say. And the assistant that I have here isn't particularly smart. The only thing the assistant really does is it says hello, then it checks whether or not you're happy. And if you're not happy, it tries to cheer you up. That's the only thing that this assistant is trying to do. But one thing that you can kind of see, though, is that we can say, well, the conversation kind of happened like, well, we say hello first. Then we say that I'm unhappy. Then I try to cheer you up. And then I ask you if that helped. And if it did, well, then I'm going to tell you this. And if that didn't help at all, then I say goodbye. That's basically what these stories tell me. I'm not suggesting this is a good assistant, right? But this is what these stories are doing. And the way that Rasa is set up is that we can at some point say, well, there's basically two machine learning systems that are happening. On the one end, we have this one machine learning system that takes text as input, and then it does a classification of sorts, and we call that natural language understanding as a task. And the main thing that it tries to detect are these intents. So just a classification task. What are you trying to achieve? What's the intent that you would like to communicate to us? And I hope you can see that, yeah, we've got like training data for that. And then here, the idea is, well, given an intent that I currently have, and also given the conversation so far, what is the next action that I should take? And this is not going into an NLU model. We call this a core model. And it's a different problem because we might need to predict multiple actions that follow up on each other. But the idea behind the stories file is that this is training data for the core model. So we've got one model that tries to predict the next, sort of the current intent, and then with this other model that can predict the next action. That's kind of the idea. And we try to, and all the models that we have here, by the way, are just Python code. It's all open sourced. There's some TensorFlow stuff happening inside of this model over here, but all of this stuff is open source. So that also means you can add your own models if you would like to do so. And I guess there's one other file that I'm just going to briefly show you. There's this domain.yaml file, and then I'll just give like the quick Rasa demo. But you've noticed in the story that we've got these intents here, and then we've got this action. And this action is something that we have to define somewhere. By and large, there's mainly two types of actions that you can do. One action is, well, we just give you some text back, and it's always going to be the same text. Another action is, well, there's just this Python function somewhere, and we're just going to trigger that Python function, and whatever the Python function tells us we should send back, that's the thing that we will send back. And that's nice because it means that you have this Python code that can retrieve items from a database. However, you do have to define all of these actions somewhere. We've defined our intents into this NLU YAML file, and we have to do the same thing for actions, but we do that in this domain.yaml file. And this is more of a settings file where all of your actions are defined, so to say. And what I can do then from the command line, just to give like the quick demo, is I can call Rasa shell. And what this will do is it will pick up a model that I've trained beforehand that's in this models folder. If I type Rasa train, it will train a machine learning model on my behalf. And what you can then do is you can just talk to your assistant and you can try to break it and play around with it. So just to give like the simplest of simplest demos, I can say hello. It says, hey, how are you? I could say something like, I am sad. And then it tries to cheer me up. In fact, it gives me an image. So let's try to put that into Google, see what happens. Google Chrome, new window, right? If we put that image in here, we get a cute tiger. So it's trying to cheer us up. And then if we go back here, it asks, hey, did that help you? And I can say no, and it says goodbye. It follows a story that I've shown you earlier. Now, the idea here is, of course, is that this story that I've got over here is super, super simple. It doesn't necessarily resemble something that might happen in real life. If you're ordering a pizza, this story file is probably going to look substantially different. There's the hello part, there's the what pizza would you like part, can you tell me what you would like on the pizza, what's your address? You can imagine that this story is definitely more involved. But I hope that we see this distinction between next action and predicting your current intent. So let's quickly exit out of this. And what I've shown you so far is the training data. What I've not shown you yet is the machine learning part. Like, what are the machine learning components that you can use to actually train these systems? And all the machine learning stuff is effectively defined in this config.yaml file. And I'll uncomment a few things here. And this is not everything fits on screen there, but the idea is that we've got this config.yaml file, and that we have all of these components that together are the pipeline that makes the prediction for the intent. I'm assuming that a lot of you are familiar with scikit-learn. Would I be correct if I said that?
Yeah, I guess this is a pretty accurate assumption.
So this is like the pipeline in scikit-learn. The only difference is this is defined in YAML instead of Python code. Lots of people say yes. Okay, I'll take that as a yes. That's a really convincing yes. Okay, so like a scikit-learn pipeline, you've got these pre-processing steps, right? And we also have that here. It's just that they're a little bit more specific towards text. So you got to imagine at the moment, what's happening is we have text that comes in. And basically the way the pipeline works here is text is turned into this message object. And every time that it passes through a step in the pipeline, more information is added to the message. So you can imagine, suppose the text was something like, hello world. Let's say that this was a text. Then the first thing that happens here in this white space tokenizer is that the message is split up into this list of tokens, so to say. And for English, that's usually very easy to do because you can just say there's a white space, let's split them up into separate words. And now this message has this tokens property that's attached. And after that, we pass it through a regex featurizer and a count vectors featurizer. These are all things you might have heard from scikit-learn. And what that actually does is it takes this message and it adds some sparse features to it. So you can imagine things like, okay, which words are being used, and we kind of get this training, this X matrix, so to say, of sparse features that's attached. And like eventually we will get to classifiers and that sort of thing, but every step in the pipeline here just adds another message. That's kind of the idea. And this also brings me to why I would really like to talk more to people who do non-English, because you have to imagine if you're Rasa, like in our research team, we have a couple of data sets that we run our benchmarks on. Most of them are English. Some of them are German, and some of them are Spanish. But if I think about the different tools that I have at my disposal here, for English, the white space tokenizer works quite well. I don't know for 100% certain if the white space tokenizer works for Arabic as well. Like I can imagine that it might, but it also might not. Currently, we're doing some tricks with count vectors here, which make a lot of sense for English. We've also got this lexical syntax featurizer, which does things like capitalization. Is the capital letter in a sentence, or is it lowercase? And you know, I can definitely imagine that this doesn't necessarily translate super well to every language. And moreover, what you can do here is you can add a spacey component, such that you get pre-trained word embeddings for English. And I'm really, really sure that you cannot use pre-trained English word embeddings if you're interested in making a virtual assistant in Arabic, right? So there's all of these separate tools that we like to suggest to people that we think might help build you a good assistant. But one thing that will be a shame is if these tools only end up working for the English language. So a project that I've started working on internally, like this is something I'm doing to help the research team, is I'm trying to figure out what tools that we can add here to also make sure that this trick works for non-English. It's not going to work for us if people send us their data sets, because if you're a company and you're building a virtual assistant, probably your data set is like private data and you cannot just go ahead and share it. So it's not going to work for us if we ask people for data so we can run the benchmarks. So instead, the tactic that I'm trying to do is I'm just trying to listen to people. If they say, well, here's a tokenizer that works really well in my language, then I'm trying to make sure that that is available inside of Rasa. What I'm also trying to do is I'm trying to add embeddings for all sorts of different languages. And what I'm trying to get to is I've kind of started a project where we have more pipeline components, more than the ones that are just inside of Rasa. And the first project that I've open sourced this year with that in mind, whoops, I need to close up this one. There we go, is this project. This project is called Rasa NLU examples. And the whole idea is that I'm going out there to try and find tools that should work for non-English languages. What I've got are some tokenizers. So for Thai, I've got a separate tokenizer, but I've also got one for Stanza. What these tokenizers do, by the way, is not just taking a sentence and splitting it up into separate words, but what they also allow you to do is things like lemmatization. So instead of saying he likes dogs, we might be able to reduce that down to he, like, and dog. If you do this, then your total vocabulary size is a lot smaller, so that can be very convenient. But the main thing that I think I've added that a lot of people like to play with are these dense featureizers. These are these pre-trained word embeddings that I'm trying to make available in lots and lots of different languages. In particular, a word embedding that I thought was pretty cool is this fast text is pretty cool, like it has support for Arabic. But there's also this other featureizer that's known as a byte pair featureizer. There's a question coming about dialects. I'll pick that up in like a minute. There's one thing I just want to show you here. So this byte pair featureizer, what's kind of cool about it, it's created by two German researchers, and they have a cool trick for making these embeddings. But what they have done is they have taken every language that they could find on Wikipedia, and they've gone ahead and made these pre-trained embeddings for them. So if you go to their website, which is this one, has to load, they claim to have 275 languages on there. And you can scroll down. There's a couple of examples, but they have this very, very long list of languages. And what's cool about this is that they also have a couple of dialects. I'm pretty sure they can't have every single one, but here you, for example, can see, well, there's a variant of Russian that's being advertised here. I know, for example, that Frisian, that's a Dutch dialect. And there's Welsh here, which is this category of languages that they have in England. It's like an English variant, also a dialect. So I remember checking this out and thinking like, oh, this is great. 275 languages, lots of these pre-trained embeddings. It's going to help out a whole lot of people. This is good. But here's, again, something I don't really know for sure. These embeddings are trained on Wikipedia. And Wikipedia is great because it has like lots of language on there. But if you look at the text on Wikipedia, and if you consider the text that people like to type when they're typing into a chatbot, it is a completely different style. Wikipedia tends to be quite formal, whereas if you type something in a chatbot, it's really informal. And also it's present tense if you're typing in a chatbot, and Wikipedia is definitely more about history and stuff that happened in the past. So already here, I'm having a little bit of issue with assuming that this might be super helpful for chatbots. And to make things like a little bit worse, what you're able to do here is you're able to, you can select how big the vocabulary for the embeddings are going to be. You can also select what dimension of embeddings you'd like to get. You can do that on the website. But what you can also do is just have a look at the UMAP projection. So you can sort of see what the embeddings compress down to. And if you have a look at Arabic, right, something that's a little bit weird is there's this really, really big cluster down below here where I can safely say that these are Arabic characters, like this is not English. But at the same time, if you scroll back up, it also seems like some English is mixed in for some reason. And then you consider, well, this is trained on Wikipedia. I can't guarantee that the researchers cleaned up the data banks before they trained these embeddings. It's something that might be happening here. And another thing with these pre-trained embeddings, I think it's not a concern here, but in general, it's something to think about. If you look at how these pre-trained embeddings are trained, something like the cat is hungry, let's take that sentence. Then the way that some of these embeddings are trained is they take a look at this word and they try to predict the next two words using this word as input. So if I think about what's happening here is there's some sort of neural network. I'm just going to quickly draw that out like so, where cat is going in here as some sort of input where everything here is a 0, but there's a 1 here. We have some sort of feed forward layer, and then we have some sort of label here that predicts the next couple of words. But the way that this is being applied is they predict the next word in order. And I believe Arabic is not from left to right, it's from right to left. So then I can wonder, is this trick even gonna work? Like, independent of the data quality and the fact that there's like English still in the data source, I can also imagine just because of the nature of the language, we can't assume that algorithms that work very well in English are going to end up working very well on other languages. So as I was doing my best, to like properly open source all of these tools for Rasa users by taking all these pre-trained embeddings, I kind of also very quickly came to the conclusion that although what I'm doing is really noble, it might not be very effective, mainly because, in the end, I don't speak Arabic, so I cannot judge if these embeddings are of high quality. So I kind of needed this tool where people can just try out these embeddings real quick and hopefully, therefore, also report back to me if any of these tools make any sense. So that's kind of the position that I found myself in this year. And this is also something that's been motivating a lot of my open source work. So I'm about to do a demo with everyone here, but now might be a good time to answer some questions because I saw some coming in into the group chat. Also, I'm hoping that everything that I've said so far makes sense, and if it doesn't, now would be a great time to ask questions. So someone is mentioning that aren't most language model using bidirectional analysis. This is definitely true, but not all of them. And that's kind of the thing that I'm a little bit afraid of. I think even fast text at some point takes like, it looks at both the words before and after. But also there, a lot of those tools are benchmarked on English. So the main thing I'm trying to get across here is that I don't think we should assume that the algorithms that work well for English should also also work on Arabic. That's the main thing that I'm personally at least a little bit afraid of. Somebody is mentioning Arabic, and I just want to point one thing out. If you go to the Rasa NLU examples repo, you will see that I've added a ticket for Arabic. So that's definitely something on my roadmap. I would love to learn if these embeddings make sense. Like if you tell me they're useful and if this is a blocker for you using Rasa, you can just let me know because this is on the roadmap for the examples repo. So that's so I'm getting confirmation that I should implement this. So that's a good sign. Code switching is very common in Arabic, especially for scientific terms, which could explain the English words popping up. That's true, actually. There's definitely some sense there. I can also, like in Dutch, there's also some English in the language, even though it's like a reference to an English term as opposed to like, yeah. So that also makes sense why they exist. That's true. How would stories fit the example of ordering a pizza if the user differed from the path set? Okay, there's someone mentioning a tool real quick. Just check that. I hope I pronounced it correctly. Camel? Did I spell it correctly? By Obeid. Maybe I should add NLP. Oh, Camel, my bad. Open source Python toolkit for Arabic. Okay. Rasa NLU examples. I'm adding an issue right now that I should go ahead and read the paper.
Just want to point out, we've also allowed participants to unmute if they have something that they want to say verbally, if that's cool with you, Vincent, as well.
Yeah, sure. Go ahead. No, like this would be a great time to ask questions. And also, I like this sort of feedback. If there are tools that you think I should consider, I like to have them like at least on the issue list so I'm aware of them.
So yeah, guys, feel free to unmute and ask a question if you have something you want to discuss verbally, or drop it in the chat. Either way is fine. Thank you.
In the meantime, Abdullah, could you share the, oh wait, the Arabic whatlies link. That's the one. I forgot it. What I'm now also doing is, I believe there was this Colab link that was shared beforehand. If you're interested in participating and actually coding the next part that we're going to do, what you should go, yes, perfect. You should go into the chat and you should see a link and you can use that link to participate in what we're about to do. There's an install command that can take a while, so it's pretty good to maybe run that. And I'm also hearing about a lematizer. So again, I'm going to the, I should leave it open, I think. Rasa NLU examples. GitHub link. GitHub link, and I can just add that. Also, lematizer. Check it out.
Also, Vincent, there is an Arabic tokenizer that was posted by Zaid Riafi, which we have hosted a couple of months ago, and I think we should check it out.
Could you repeat the? Oh, let's have a look at that one. I think I have a couple of them in the issue list, but I just want to check if. Nope, that one's new. We'll definitely add it. Oh, I like the logo, by the way. It's nice and clean API. It's, yep, okay, add it to the list. Add it to the list.
Yeah, and I think we have the creator as well with us today.
Sure. Why are there two count factorizers? Okay, that's a really good question. So there's somebody asking, like, they saw the pipeline over here, and I've only spent a little bit of time on it, but they probably observed that there is not one, but there are two count factorizers in here. So people might wonder, well, why is that? One thing to point out is that this count factorizer has settings that this one does not. And in particular, the main setting that's relevant is the analyzer setting. The idea behind it is that if I have a word like university, if a user were to spell it differently, let's say univer city with a C instead of an S, which is the wrong spelling, then an issue that might arise is that this word is totally not recognized. Even though it's really, really similar than the previous word, the fact that it's just, spelled wrongly means that it doesn't occur in the vocabulary. So the idea is that what you can do is you can say something like, well, let's just, instead of putting this word in our vocabulary, let's just look at all the bigrams like UN, NI, IV, VE, and also the trigrams like uni, NIV, IVE, VER, etc. Like if we put all of those things in our vocabulary, then we might be robust against spelling errors. And that's why usually A lot of people like having this count vectors featureizer here. It's just an insurance policy, if you will, against misspelling. That's why we have it. I think there was one extra question.
Can I ask a question, if that's possible?
Yeah, go ahead. Go ahead.
Yeah, so thanks, Vincent. It was actually a very good presentation. I already worked on Rasa for like 6 months or so when I was working on my master thesis, and I think it's a very good tool, although the interface isn't that good compared to Google Dialogflow. I don't like Google, but I'm just here talking about the interface.
Sure.
Anyways, I think the only thing that can be a challenge when making an Arabic NLU would be that in Arabic, the vowels, the short vowels actually aren't written in the words. For example, one word can be written for 3 letters, and it can be pronounced like in 7 ways. And in each pronunciation, it has a different meaning with a different intent. So can a tokenizer tackle that issue?
Just so I understand correctly, because again, I'm not familiar with Arabic, is it the phenomenon where you spell the word the same way, but depending on where you put the emphasis on the word, it is a different meaning? Or is it different than that?
It's a different for that. For example, if you write a word with only 3 letters, like there's a word in Arabic, it's aqd. It can be pronounced in different vowels, like aqada, iqd, aqd. And in Arabic, you actually don't write the vowels. So the chatbot or the conversation agent actually can't recognize how the word would be pronounced.
So one thing that, so there's one thing that will help you here. It's a great question though. I'm going to try to answer it, but I'm going to make a couple of assumptions about Arabic, and if they're false, you should just say so. But one saving grace here, let me just get the drawing tool, is that we have this diet classifier that's in here. Now, very basically put, the diet classifier is a neural network. It has a transformer in it and a couple of dense layers. But you can imagine, right? I think I'm allowed to say, well, you're probably not going to have just a 3-letter word every single utterance. You're probably going to have like the 3-letter word and maybe 2 other 3-letter words when somebody's typing something back. And even if you, so there's a little bit of wiggle room in the sense that, well, we can at some point say that typically, even though this word has many different meanings, usually if people use this particular word in this particular chatbot, it means that they are referring to this intent. So, and one thing that will help you out here is typically, if you have a count vectorizer, I'm just gonna do it phonetically. What you pronounced earlier sounds like act, which is the Dutch way of saying it, I suppose. I'm hopefully not pronouncing it very wrong, but I'm approximating here. But that can be activated, while there might also be some other word activated. I'll write nom just randomly, but it might be that these 2 are activated at the same time usually. And since we have a neural network here that just, does the feed forward thing, it can at some point learn the pattern that only certain intents are triggered if both of these words are activated at the same time. That is something that a neural network might be able to pick up. So even though the tokenizer on its own is not enough to pick this up, as long as it's surrounded by these other words, you still have a lot of going for you. And there's also, the chatbot's not supposed to do all of the Arabic language. Typically, you're only focusing on a small subset for a specific use case, like ordering a pizza, for example. So typically, that might be a way of thinking about it to make it more manageable. But if I'm missing something here, feel free to tell me.
Actually, that was a comprehensive answer. Thanks.
Okay, I will show you. So would like to do now, because I think this might be something that's fun for the entire group, and this we can sort of do live coding together. Because one thing I'm kind of curious about is, I'm making all of these tools, so a very nice thing to get answered is, do these tools even work? And also, do they work in the same way as English? So one thing that I've been making this year is this tool called whatlies. And the idea behind the tool is that I want to figure out what lies in word embeddings. And there's kind of a joke in there, because if you think, lies, and that's also an interpretation of the word. It's because lies has 2 meanings that I figured will be a cute name, because a big problem with word embeddings is that for a single word, you might have multiple meanings. And I'm assuming that's the same in Arabic. Like single combinations of characters can probably be a word which can have multiple meanings, even though it's written down the same way. I'm just checking, but I'm assuming that's a universal property of language. So what I've done, and that's the way that this library works, is I have a library that basically has a data frame, but for word embeddings. That's the whole idea. So, and the way that it kind of works is we have a language backend that can be byte pair embeddings, that can be spacey, anything that generates word embeddings. And what you can do is you can give that language backend text. Like you can say, hey, here's man, here's king, here's brother. And if you give it a list of strings, the output of this will be an embedding set. And an embedding set is the equivalent of a data frame, but for word embeddings. And the whatlies library basically puts like a lot of visualization tools and tools in general to help you understand if the word embeddings that you have, if they are at all useful. And one thing that I've never done before, what I'm actually kind of excited about that I can do now, I've never really compared embeddings from the same source from different languages. I guess I've done it for Dutch, but I've never really done it for Arabic. So to give a small demo of what you can kind of have, and I've installed everything just now, but oh, wait, this has to download, I think. We're gonna have to wait a little bit, but is this thing loaded? Let's just check. There you go. So what's happening right now is I'm basically configuring two language backends. I've got the byte pair embeddings for Arabic, and I've got the byte pair embeddings for English. You can check the documentation for these byte pair languages. The first parameter that you give it is the language code. And then in the case of byte pair, you can say, well, I want to have like the big dimensions, and I want to have a very big vocabulary size as well. And then this automatically download the relevant byte pair embeddings for you. It's doing Arabic right now. It's going to do English in a bit. And while I'm assuming that this is happening on your screens as well. So what I just very briefly want to do in the meantime is show you the documentation pages, mainly because I think it's relevant to show that, I support a lot of different languages. So right now we'll be using byte pair languages, but I also support GenSim, anything that's supported by Hugging Face. TensorFlow Hub is also supported. There's some BERT models from the sentence transformer package. I also support Spacey and fast text. So if you can find Arabic word vectors in any of these backends, then you can use this library to do what you're interested in. Another nice feature of this library is that any of these language backends can automatically also be plugged into a scikit-learn pipeline. So that means that if you're doing, let's say, sentiment analysis, you can have your scikit-learn pipeline over here, and you can just put a language backend as a featureizer in here. And just from doing this, you will get the language features like the word embeddings that are part of the text that you feed it. So it also means that if you're interested in just benchmarking how good embeddings are to predict something, then you can also just use it in combination with scikit-learn for your task. Okay, so I think this is now done downloading. What's pretty cool about the way that this works, I'm just going to do it for English first, is if I want to get like the embedding for the word king, this is the syntax. You just use the square brackets as if it's a dictionary, and it will just get the embedding for king. You can also do sentences in here. That's completely fine. It depends on the language backend, but typically we add all of them together. Like we add all the vectors together, so to say. And what you get back is this vector object, this embedding object, I should say. And an embedding object has a name, and it also has a vector. Oops, shortcut. Which is just this NumPy array that you're probably used to. But this is really convenient because one thing that I can also do is I can say, well, let's just give it a list of like king and queen, let's say. Well, in this typo. In this case, we're not retrieving one embedding, we're retrieving two. And this is an embedding set. So this is like the data frame, so to say. And what you can do is you can get the length of it. It'll tell you two, because right now we've got like two things in there. What I can also do is I can say, well, please parse that to like a proper NumPy matrix. And in this case, it'll have a specific shape. It'll be 2 by 300, because for both embeddings, we have 300 dimensions. I can also cast it to a data frame. There's a bunch of useful utilities attached to this. That's the idea. And what you should also be able to do, and I don't know how I can do that on my keyboard, but if you take the Arabic language backend, you should be able to. Oh, the right and left are also inverted, I see. That's interesting. There you go. But you should also be able to get like the embedding for Arabic, and it should just go ahead and work. And you should also, again, be able to query the vector, and it's like a data frame, but for language. That's the idea. What you can also do, given a language backend, and this can be interesting. Like I like to also judge a model sort of qualitatively, but in order to do that, one thing that I typically really like to do is I like to make plots, because I can look at 300 dimensional vectors, but those typically don't have too much information. So instead, what I usually like to do is I like to make these similarity charts. And just to, again, show you the code and that you understand how it works, I have a dictionary here, which people have helped me translate, thanks again, where I've got the English word, and I believe this is the correct translation. Don't blame me. Abdullah did most of this. But I have reasons to believe this is just simply correct. So I have the English word, and I have got the Arabic word. So if I take that dictionary and I take the values of it, well, then I get all the Arabic words. And if I then turn it into a list, well, then I can use that, just like I showed you before, to get all the vectors and all of the embeddings out. And what I can then sort of do as a chart, let's say that I have the vector, sorry, let's say I have the vector for king, and I've also got the vector for queen, let's say. Well, what I can then do is I can calculate some sort of similarity between those two vectors. These are two NumPy arrays. So I can calculate like the cosine distance or the Euclidean distance. These are all things that I could go ahead and calculate. And if I calculate for every pair of words that I have in my list, then I might be able to see clusters appear. And if you followed all the steps so far, I hope I'm not going too fast. But if you do that, then you might get a chart that looks something like this. And one thing that's nice to see is that matplotlib is able to handle these characters. That's definitely a nice thing. But to me, the thing that I find the most interesting is that if I if I look at the English version of this chart, then I can see some clusters appear. Like over here, I see man, woman. That's a pretty decent cluster. I've got some animals over here, and you can kind of, if you squint your eyes, you can kind of see a cluster appear over here as well. And here we've got some things that are about students and schools. And again, we kind of see this cluster in the lower corner. And one thing that I found relatively comforting is that if I scroll up and now look at the chart that's here for Arabic as well, it's certainly not the same chart, but I do see at least the animal cluster appear again here, right? It is something that appears in both languages. The one thing that does seem to be a little bit different, like English here, I would argue has like a slightly stronger cluster for man, woman, king, queen, brother. And there's a little bit less of that maybe here. It's still kind of hard to say. But it's charts like this, at least, that make it even possible to compare these language embeddings. The one thing, again, that I don't know is, does this make sense to you? Like, this might be a good time to like start asking questions again. Like, I cannot really judge if the clusters that we see here, you know, if they're sensible or not. So I can see some overlap with what I see below here, but it feels less strong of a clustering than what's happening here. So I'm assuming people are sort of playing around with this. And while people are playing around, if you have questions, now might be a great time to ask as well. I saw one question about why we add word vectors as opposed to average them. It depends on the language backend. So I think Spacey takes there's one Spacey version where I think they took the average, and another Spacey version where they took the mean. It kind of depends on the version of Space, if I'm not mistaken. And like, it's hard for us to do something that's consistent, so we just use whatever the backend language does. I think fast text adds them. Jensen might average them. It depends on the language backend. Ah, so this is not inverted. That's the issue, if I'm not mistaken. Like it needs to be like from left to right. It needs to be from right to left instead of left to right. Is that what people are saying? Ah, okay. I'm going to make a note of that. People are referring to the BD package. There you go. Python Arabic Reshaper. This is a really cool package. I am definitely keeping an eye on this one. Okay, I'll keep this tab open and I'll have a look. It might be nice if I'm able to add stuff like this to whatlies as well. If that makes the plots prettier, that's definitely a feature I wouldn't mind adding.
So I think we have a question from Saad. Saad, yep. You can unmute yourself, I think, Saad.
Hello, can you hear me? Hello?
Yeah,
yep,
we can hear you.
Yep, you're there.
Okay, so thank you for your presentation. For my understanding, the embedding that you used here is from Wikipedia, right?
It's byte pair embeddings, and their documentation page lists that they are trained on Wikipedia. Yes.
So I think you're gonna struggle with the slangs, right?
Oh,
so,
definitely.
So we have like multiple slangs. So we have slangs in Saudi Arabia. Also, we have slangs with the Arabic countries. So what can we do to face this problem? So I think if we want to use this, for example, in a hospital as a chatbot, and we're gonna assume that a lot of people is gonna contact with our chatbot, and so we're gonna have a lot of slangs. So how can we like solve this problem?
It's a really good question. So here's my version of the solution, but like I will say, like, slang is also an issue in English. It's like Wikipedia is really bad at simulating like actual conversation, and slang is like a really good example of that. Also dialects, I think, is what you alluded to. So a very valid concern. However, here's what usually happens. Like if you have an embedding, like a numeric array comes out, right? That's how that works. But this is just a feature. This is not the machine learning model, so to say. In fact, if you have a look at this diet classifier, let's say that I have some sparse features going in from the count vectorizer, but I can also have some dense features that are going in. Let's assume that the dense features are coming from this embedding. Effectively, what will happen, right? And I'm drawing this out like very schematically. But let's say that we have our diet algorithm here and we're doing intents eventually here. The only way for diet to actually learn what is happening is to actually look at your training data. So that means that there's a gradient signal coming from your intents, and that's going to update all the weights that we have inside of this system over here. And if that means that certain slang words don't exist in your embedding over here, then it also means that your dense representation here is just going to be all zeros.
Right.
So how is diet going to compensate? Well, diet's just going to have a look at the sparse features that you do have, because that's the only signal that it can learn from. So how do you fix this for your specific use case? Well, data. Make sure that your data set that you collect is representative of the use case that you're trying to solve. And that's the way that you're going to get robustness in. In general, a thing that is good to remind ourselves of is that these embeddings are probably trained on a general use case. Probably they're not trained for your specific hospital use case or legal use case or whatever your specific domain is. These pre-trained language models typically don't contain the jargon that's specific to what you're maybe interested in. So your best bet is always to be mindful of the data quality instead. I don't blame you for this, but a lot of people tend to focus in on the, oh, can I get like the highest accuracy and all of that sort of thing? Can I do the grid search? Can I try out all these embeddings? It's definitely fair, but usually the labels matter way more. That's my
right. So I'm PhD student, and my focusing on natural language processing, and like, I don't know, I have an idea, like, what if we use social media to just train our embedding? So in social media, we can specify the location, for example, country or city, and trying to like retrieve all, for example, tweets or posts, and then trying to...
But it's the same problem. The way that people talk to each other on Twitter is probably not representative of the way that people are going to talk to your virtual assistant.
Right, but at least it's like slang.
So it's probably better. That's possible. But still, for your specific chatbot, you must have these labels, because otherwise you don't have the gradient signal. That's a thing you need. Okay. On your topic, though, I do want to mention one thing, because it might inspire your research. What I'm doing currently as an experiment is I'm aware of the fact that Wikipedia is just a bad source. It's there, I get it, but I prefer to have a different backend. So I've downloaded this thing called the Open Subtitles dataset. The dataset is from movies and like the subtitles that you have there. And the interesting thing about that, if you think about what is captured there, it's actual conversations between people. It won't be perfect slang, but there will be some of it. But at least it won't be super formal. It won't be super historical. Like a lot of these Wikipedia issues you shouldn't have with it. So I don't know if that exists for Arabic. I think that's open source for like 60 languages. But that is something I'm currently exploring as sort of an alternative to Twitter, but with definitely the same vibes as what you're describing.
Okay. Thank you very much. Thank you.
Great question.
Hi, Vincent. This is Saleh.
Hi.
Thank you really for the presentation. I really like it. I came from business background. I used to be a programmer before 7 years ago. I still program a little bit, but now I'm back and interested more into the NLU and the chatbots. I'm really curious to build something for business focus. So my question is, and sorry if it's maybe naive, but when I look into businesses, you look into industries and you look into specific domains. When you build a chatbot for telecom, it's different from hospitality, for example.
Oh, yeah, correct.
And the problem here, where is the words and the conversation coming in? You mentioned about movies, you mentioned about Wikipedia, but are there other sources for domain-based, for business-based that we can get off? I'll start with English. Not
You're gonna love the demo that I'm going to show after. That's the only thing I'm going to say. It's the main thing I want to say about it. I do want to do continue your question, but I think I'm going to answer it with a demo that I'm about to show you.
Yeah. So simply, what sources do we have that we can grab domain-specific, industry-based specific discussions that we can build intelligent chatbots on this?
Sure. Now, so there's two things that at least on Rasa's end that we sometimes recommend. Like in the end, let me put it this way. Like the one thing that is always kind of weird about this space, people will interact with your assistant in ways that you simply did not anticipate. I'll give you an example. I'm building a chatbot in my spare time. That's a video game. The idea is it's like a text-based adventure game. You have to type what the person is supposed to do, and I'm building a chatbot thing around that. And I've shown that to some colleagues to sort of start playing with it. And the point is that you pick up items and that you combine them in puzzle, and that's the point of the video game. I've shown this to a colleague who never played a video game before, but she has seen her husband play video games. And when she sees her husband play video games, it's usually about like guns and destroying stuff. So she thought, oh, it's a video game. So that means that I shouldn't pick up items. I should try to break everything. The same thing will happen with chatbots out there, because you're not going to be able to perfectly predict how users are going to interact with your assistant. The unfortunate thing is that you're probably just going to have to carefully expose it to some users and as quickly as possible learn from that. That's usually the recommended way. It's at some point, I might even argue it's not really artificial intelligence anymore. It's definitely more psychology and like empathy for your users that are going to help you design a good system. That said, typically if you're starting out with a virtual assistant, you probably are already a company, and you probably already have some data coming in from customer feedback. Like if you're a telecom provider, then you probably have like a call center where you already got some feedback in, or you might have like a Twitter account where people talk to your brand. And that can be a really good source of inspiration, so to say. And that's more the place where I might start than to just assume everything from Wikipedia.
If I might add, we actually, for my company, we had a lot of data coming from Twitter, and we also had live chat. But what we did is that we are using Rasa. What we did is that we deployed it using menu-based chatbot, and people don't really use menu; they type. So we deployed it, I think, 2 months ago, and we have over 150,000 sentences. So we are actually now building Rasa using this data. So I think this is a good starting point to anyone who wants to collect training data. They can just start like this.
Another thing that we sometimes do internally is, you start out with some intents that you think are reasonable, and then you just show it to a colleague, and again, try to learn from that. That's you have to start somewhere. And your first version is probably not going to be great, but by showing it to more and more users, hopefully you get to be able to learn. This was a nice comment. Thanks.
Hello. I just want to add a small thing. First, thanks for the nice presentation.
Thank you.
I'm relatively new to the NLP realm. I'm mostly into other sorts of machine learning.
Mm-hmm.
Anyway, a while ago, as I was starting into NLP, I was really interested in chatbots. So I reached out to a few friends. That's when I realized that it's not that easy. Anyway, the thing is, with the kind of businesses that actually need, not just want, that need chatbots, they usually have a huge amount of employees who actually work to reply to customers. Especially in chats, live chats, and customer service.
Yep.
So they actually do have a huge amount of conversation data that can be used to train models for their specific use cases.
Mm-hmm.
The problem with this kind of data is it's not available openly. So
so the company
and most companies, most companies won't give it to you for free.
Yes, and I will say, privacy reasons are good reasons. I don't want to suggest that that everyone should share their data, but I do acknowledge that what you're saying is definitely a small problem because we can't benchmark as much anymore.
So the data is sort of available, but it's just not openly available.
Yes.
And that's a big problem in the Arabic language in general that should be tackled.
I mean, I think privacy concerns are fine, right? Like if you're a bank, right, you can't just share every conversation that you have with your clients because a lot of stuff should be private. But you are right. But in general, I think even for English, there's not like an epic amount of good chatbot data available. I think there's more data available for images and like detecting things in that than like a proper NLU use case where you actually have a proper conversation and that's something that we benchmark against. So in that sense, I do want to give you a little bit of hope in a sense that what you're describing is also an issue in English. It's not a uniquely Arabic problem, I think. But availability of data is definitely a huge issue. That's just a fact of life. That's true. Just to check, are there any more questions? Because I kind of want to. Oh yeah, one more, sure.
I have a tiny question about the embedding vectors.
Yep.
By any chance, since those embeddings for Arabic and English are not directly related, by any chance, would they be similar for counterparts? I mean, Arabic and English words with the same meaning, with the shared meaning? Would the similarity be high between them?
You would hope so, but it's not a guarantee.
Yeah. I would expect it to be more similar in translation
I mean,
setting.
yeah. So what I know is that what some people do is like if your language doesn't have a lot of data available, I know that some people go to like Google Translate, first translate their sentence into English, and then throw that into an embedding and then use that embedding. Some people try that. A few issues though, like that you will have to deal with this translation error. Translations won't be perfect. And second, the thing that usually isn't captured very well is this cultural aspect. So I'll give you an example. If in Europe you open up a newspaper and the newspaper is about Brussels, it's never, then in that case, I can guarantee you that typically the news will not be about Brussels, the city. Typically, it will be about the European Union that has its headquarters inside of Brussels. So whenever you see the word Brussels appear, it's usually about politics as opposed to it's a city. But it uses the same token. Now, if you were to translate this, you might get the embedding for the city as opposed to the embedding for the government, because that's something that's sort of missing maybe. And that's kind of the risk with this translation, unfortunately. It's not a bad idea, but there's these edge cases that you're not insured against. That's the unfortunate fact here. That said, I think we've answered most questions.
Okay, so I'm sorry for the interruption. So lastly,
go ahead.
Can we compare the similarity between the Arabic and English now?
The best thing that you can do is stuff like what I'm doing here. And the thing is, like, if you have the translations at the ready, you can do this sort of thing. Actually, I'm going to do some live coding, and we'll see if it works. Actually, no, wait. I can already say it's not going to work. And I'm going to explain it with the chart that you see below here. If you think about what's happening when we do word embeddings, right? One way of thinking about it is to say, well, these words are going to cluster. They're going to cluster in like a high dimensional space somewhere. And probably the word cat and dog, they're going to be close to each other. And the word man and woman, they're going to be close to each other. But that's mainly because they're going to be in the same cluster. What I'm doing here is I'm, again, taking the Arabic words and I'm taking the English words and all of their embeddings. But what I'm now also doing is I'm applying principal components to both of these to turn these 300-dimensional objects into 2-dimensional objects. And that way I can plot them. And you can see the results here, by the way. These are like very pretty Altair charts. They're interactive. You can host them on your website. But what's happening here is that we see these 2 dimensions. Note that the axes are not the same. We do have this one property that, at least for English, I can confirm, hey, yeah, all the animals are here together. We have the university and the school. We've got the students here. So I definitely see the clusters appear. And I would also assume something of clustering must be happening here, but it doesn't necessarily mean that the coordinates correspond to each other. It might be that one cluster is in the upper left corner here, while it's in the lower right corner here. Again, because it's clustering. It's not necessarily pointing to the same array. Does this answer your question?
Yes, it does answer, but from what I see, the Arabic words and their English counterparts are not too different, especially on dimension 1. So they certainly won't be as similar, but there is a little. Of course, we didn't see yet all of the 300 dimensions, but This might
Oh,
sort of
but does it hold for all of the clusters? Like where are the animals in Arabic? Is this the animal cluster?
yes, exactly.
Okay, and these words that are now sort of close by, what are these two words?
Animals also, a dog and a lion.
Oh, wait, but there's and what are the three here?
A kitten, a puppy, and a cat.
Okay, so this is the animal cluster, so to say.
Yes.
And these?
Man, woman.
Okay,
So it's sort
okay.
of similar to man and woman in English.
So there's definitely sort of a similar thing happening here, but there are things happening in the left corner here that aren't happening
King
here,
and
right?
queen. It's
Yeah,
king
so-
and queen. So it's on dimension 1. They're sort of in a similar place, but not on dimension 0.
Exactly, and it's that makes like doing numeric comparisons hard. There's no guarantee that they will be in the same place.
Especially on the other dimensions.
Yes, and that's the thing that makes it really, really, really hard. That's the main thing that makes it hard, in fact. A very valid question though, but this is also what makes machine translation hard sometimes. Having said that though, I want to maybe point out one funny thing. So, I'm kind of looking at this and I'm kind of saying, there's a cluster here, there's a cluster here, there's a cluster here as well. And this is kind of a fun user interface if I think about it. There's something really nice about being able to zoom in and out and being able to play with this. And it helps that I've got this fancy pen so I can actually do this doodle, right? But I've been thinking like, hey, maybe some of this language processing stuff that we're doing, I can give you these embeddings, but the main thing I'm trying to do to you is I'm trying to make people understand. So maybe we should stop looking at it as a machine learning problem, and maybe we should start thinking, maybe it's more of a user interface problem. There's something to be said for that. So maybe, considering that I have this Jupyter notebook and I can add JavaScript to it, maybe I can combine some stuff. What I might be able to do is to make it easier for you to play around with Arabic embeddings, and maybe also something makes it easier for you to do labeling. So here comes what I think is the coolest demo that I'll be doing this year. I do need to find my notebook. I think it's this one. Yeah, I think it's this one. There you go. And if I now do the F, yes, okay, this is gonna work, perfect. So the demo that I'm about to show you, it is English. However, all the tools that are in here should be available for some version of Arabic as well. What I'm doing here is something that you saw before as well. I have my text that's going through some sort of language backend in whatlies, and that's going to give me this embedding. And then I'm not going to use PCA. I'm going to use this different embedding technique, one that's called UMAP. And it's my favorite. Like UMAP, it's the best. It's something really cool that they do. The main thing that's really nice about UMAP is it does the clustering part way better. It really tries to separate things out into separate clusters more than what principal components do. But the thing I like is it's going to give me a two-dimensional representation. Here's what the charts look like. And by the way, the data that I've given it here is like data from my chatbot. It's unlabeled. It's the chatbot that we have on the Rasa website. And these are all the chit-chat examples that are in there. And what I can do now is I can kind of zoom in. And I can just kind of start exploring some of these clusters. I can say, do you know French, other languages? These are all sorts of questions that users are asking about, like, hey, Rasa bots, do you also speak something else than just English? I got a cluster over here that's apparently about finding restaurants. Right, there's a couple of those. The issue, though, is that the embeddings that you see here are based just on count vectors. So the only thing that's being clustered is a certain word being used or not. And that's also why I think there was a cluster over here, if I'm not mistaken. Yeah, so people are asking, what is your name and what are you doing? And the reason why those are in the same cluster is probably because the word what is in there, which is the best way to cluster points. So this is a cool demo, but let's go for byte pair embeddings instead. And you'll notice that we do byte pair embeddings that some of these clusters are definitely way more pronounced, right? If we compare the clusters here with the clusters here, it definitely feels like stuff has been pulled apart more. So again, we see the language thing here. That's good. And over here, we see a lot of stuff about restaurants being hungry. That's already better, right? Like it says hungry, and that's automatically in the same cluster as restaurant, even though the word restaurant's not being used here. Right? Okay, so that's nice. That's clustered together, not just based on the words that are being used, but something of meaning is a little bit attached more. But still, if I kind of zoom in, it's not perfect. Like the proximity here is not necessarily the same thing as meaning. So it's better, but maybe what we should do is we should use the universal sentence encoder. We're going to go ahead and use the one that's in TensorFlow Hub. And the universal sentence encoder is actually pretty good at doing exactly this, like taking a sentence and embedding it in a distinct way. And if I do this, you know, if you find me a restaurant, that's a nice little cluster. Do you know any jokes to make me laugh? That's a cluster. Like these clusters are nice and pronounced if I think about it. And if I start thinking about labeling, you know, it'd be cool. It'd be really cool if I can like draw a circle around this and then say, let's have a look at all the data points and give that a label. And then this cluster will go away. And then we can do the same thing to this one. And we can do the same thing to this one. So here's the cool thing. Like this year, I've been making a couple of open source tools available. What I've shown you so far is this tool that I made that's called whatlies. But I'm actually pretty happy to also demonstrate this other tool that I made called Human Learn. The idea from that tool is to make it easier for you as a human to add rules for scikit-learn. And it also has some interesting integrations with pandas. So here's one of the features from Human Learn. You can see that there's all sorts of clusters here. What I can do is I can double click, 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 get this little shape going. And this is like my selection box. I can put that over a couple of points, and then I can use and there's a trick that I can do such that I can fetch the pandas rows that correspond with those points. That's what I'm doing here. So it seems that all the points that I have here, just from glancing at this, they're all about time. There's not a perfect clustering here, right? There might be some errors happening, but just the first 10 rows, it all just seems to be about time. So what I can go ahead and do is I'm going to say, well, here's a label. It's called time. Okay, that's these indices. Let's just assign this label. And technically, I've just labeled 51 data points. And if I now were to reload this chart, we will see that this cluster goes away. And I can continue on to label another cluster and sort of inspect that. Maybe just double click, 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 double click. Let's have a look at these. And all of this seems to be about restaurants. So I'll just call this food. We'll label that. I can refresh this again. And what I'm hoping, again, this is not going to be a perfect labeling, but if you're a company, and I'm assuming there's plenty of companies, and you're interested in making your virtual assistant, and you're in a non-English language, then the thing that you need, I think, are not necessarily embeddings that are trained on Wikipedia. Instead, I think it would be nicer if you can just more quickly come to labels yourself. So if I think about the most effective thing that I might be able to do to help the community, in part, I'll definitely keep open sourcing these embeddings. I'll definitely keep doing that. But maybe I just need to make tools that make it more fun to just do stuff. Like that's something that I've seriously been thinking about, because I think we're just going to get way more labels from doing this simply because labeling is more fun now. It's not this task that we sort of go, oh no, I got to label. It's going to be this task where you can kind of say, hey, let's explore the data a bit more and actually understand what's happening. And it's childish, I guess, but it's something about like drawing and then being able to interact with it. And then like it becomes a toy instead of a chore, right? That's the thing that I find super interesting about this. And I've actually timed myself doing this. Like I was able to get like 1,000 data points in 5 minutes. Again, I don't want to suggest at all that these data labels are like the highest quality. There's probably some mislabeling happening here and there. But I'm also, so that's the main thing I kind of want to leave with. I'm also interested in looking at NLP from this angle. I don't want to suggest that NLP is just training embeddings and making sure that all these tools are available. That definitely helps. But the main hard part about any NLP task in real life is getting high quality labels. That's also why Rasa has this Rasa X product. It's a free tool, but it's something that helps you labeling. Because in the end, it's not going to be the pre-trained embeddings that will save your pipeline. It's getting proper labels instead and being able to do like high quality there. I think that's going to be way more important. So this was the cool demo that I hope everyone liked. I'm pretty sure there's going to be some more questions here, but I've basically given you the main things that I want to present. There's tons of other stuff I could show you, but I think now will be a good time to just check the crowd if there's any questions. And the final thing I kind of want to say about this, I'm using the universal sentence encoder here, which is for English, but I have also found a pre-trained BERT model that you should also be able to use for this. And I would love to hear if the pre-trained word model plus the human learn thing that I've just shown you, if it helps you label. Like hit me on GitHub if you have any feedback on that. I'd love to hear it.
So we got one question from Nicholas, I believe. What would be the next step after the first pass of labeling?
Oh, sure. So in my mind, this is useful when you just start out, right? So we might have these logs from customer service, we might have Twitter data, and this will help you get like clusters going. And the main thing I would argue here is that this is going to be inspirational for you to design your intents. So the first time that you're making your assistant, what intents are our users actually asking for? And can we like put them in? Kind of like detecting frequently asked questions. After you've done that, the next thing is to actually show that to users and see how they respond. And that's where the really more important labels are going to start coming in, because it's maybe that's also like a fun little drawing to make. So like, oh wait, yeah. So if I draw the Venn diagram, right? If the left circle here represents stuff that we optimize, and on the other side is like the stuff that users care about. The hardest part of data science is not doing this. The hard part of data science is making sure that this overlap between these two things is big in the first place. So what we've just shown is something that's really, really good to get your first labels. The next thing you got to do is just check if those labels matter to your users, because it might just very well be that you have some clusters that translate to an intent, but it's an intent that none of your users ask for. That is the next step that you got to do. How to handle out-of-topic intents. That's a good one. What kind of out-of-topic? Because there's a lot of them. One out-of-topic intent that I've actually open sourced 3 days ago. Rasa NLU examples. Did I close it already? Yeah, I did. So one type of out of topic thing to keep in mind is language, especially here in the Netherlands. It sometimes happens that that the assistant is only able to speak Dutch, but people talk English to it. So that's something you don't want to have. Like you want to maybe check, hey, is this person even speaking the right language? However, to gather training data for every single language out there that isn't the language that you're designing for, that's not going to be great training data for your system. So Rasa has this mechanism that's known as a fallback. It's a bit of an advanced topic, but the idea is that when you've done your classification with diet, there's a predicted intent. You can then have a fallback mechanism that just runs on the side. And if that fallback mechanism is triggered, it can override an intent. So the idea is, for example, one fallback mechanism could be the confidence score that comes out of diet is way too low. So, okay, we're just going to ask the user to repeat the question because we need a higher confidence before we automate something. The thing that I've made here is similar, but the thing that it does is it triggers whenever you're speaking the wrong language. And then we can ask the user, hey, whatever language you're doing, please refer back to the target language for this assistant. This is, I think, if you're able to do a fallback, that's, I think, the nicest way to handle out of topic. It's still, it's not necessarily easy, but I think this is a nicer way to talk about like outlier detection. There's usually a couple of these outliers that you can define quite well. These are typically outliers that occur very often in your assistant, and this can be a way to target those specifically. So that will be at least my train of thought. The notebook that I just shared is open sourced. I'll share the link. It'll probably get it to, I'll add it to like the Meetup website. I think that's the easiest way for people to find it. What if a message has multiple intents? How to handle them? So one way of thinking about this, I'm just going to give like an example. Suppose that the intent is, I would like to order a pizza, and it's this pizza, and I would also like to order a Coke, like the drink, the Coca-Cola. Like it can be that that's like the full sentence that you get, and there's like a couple of intents in there. One thing that you can do from the user interface perspective is to say, well, this is the moment where we're going to start a form loop, where we're going to say, okay, I think we got this information. You wanted to order a pizza and a drink. Is this correct? So what you would do is you would basically ask the user, I think this is what you want me to do. Is it correct? And if not, here's like a form where you can be more specific. It's more of a user interface way of catching that than a machine learning way per se. There is a way inside of Rasa to sort of try to detect multi-intents. It's a bit of an advanced use case. You could go there, but usually it's more of a user interface problem than a machine learning one.
Hi, I have a question.
Yep.
If we had like for designing the stories, let's say we have very different actions for the same intent. So we will design different stories following different, you know, steps or based on different intent. Like what is the history of the conversation, right? But would that affect and predicting the next action? Like for instance, let's say that for like I want to order pizza, you know, based on the entity, different actions would be
Triggered.
Triggered, yes. So would that affect the performance, or because like we're currently building our stories and we noticed that it does fail like a lot. So
what version of Rasa are you using?
1.10.11.
Ah, okay. Then you're gonna like this. So the way that this works, I've kind of focused a little bit more on the NLU part, but what you're like, what action to do next, the dialogue management, is actually a way harder problem. However, one thing to keep in mind is that we have this TED policy, and what's really just happening there, it's kind of like a time, it's not really a time series, but it's a time-sensitive thing where we try to look back on more than just one time step ago to try to predict the next best action. And that's something that we try to do machine learning-wise. It's just that it's not going to be perfect 100% of the time. So instead, what we have is we have this new feature in Rasa 2.0 that's called a rule policy. And the idea behind the rule is that it's similar to a story, but it's much more rigid. A story is meant as training data, but a rule is a little bit more like an if-else statement. If this pattern is detected, then this is the action that you should take, no exceptions. I've got an example here. Like if we ever see the intent goodbye, then utter goodbye should be the only thing that we ever send back. No matter what else happened in the conversation up until this point, if the intent is goodbye right now, then this is the only correct response to send back. This is a pattern matching system. So you can be expressive. It's not just intent and then action. You can also do things with entities and slots here. But this would be the way to maybe try to navigate that. I do think that you don't always need machine learning to predict the next best action. Sometimes you can just go on fine with these rules. And what you're saying here suggests that you might want to invest in this feature.
Yeah, I will try it. Thank you.
One thing about that, by the way, if suppose that you're trying this feature and you have a hard time getting it to work, one thing to keep in mind is we have this forum.rasa.com. We have this Rasa forum. It's for free. You can just ask questions there. And I take like a half hour basically every day to answer questions here. So if you have trouble implementing this, I would love to know, because I make educational content for Rasa as well. My username here is Koning, Koaing, but if you look for Vincent, you should also find me. If you have a problem, post a question here and like add my name and I'll gladly help you.
Sure, thank you.
Okay.
Is there any more questions?
Somebody's running Slack.
Yeah, I should have put it.
That's fine.
I guess this is it with the Q&A.
It seems like it.
Okay, guys. If no one has a relative question,
Go
I
ahead.
have sort of an out-of-topic question.
No,
A bit
go
out
ahead.
of
Go
topic.
ahead. Go ahead.
Yeah. As I said earlier, I'm just getting into NLP, and as I wanted to go for chatbots, I found that I'm getting a bit ahead of myself. So I went back and started reading Jarofsky's book on natural language processing. So any advices for going ahead after finishing the NLP basics that would help with chatbots specifically?
Like I want to be kind of honest here. I think I started doing NLP a year ago. I think I don't consider myself to be an actual expert. I have a research team that some of them in my research team have like a proper PhD. Like I consider myself knowledgeable and I can do stuff in practice, but I don't necessarily consider myself an expert. What I am good at though is solving problems. And I think the reason why I'm good at solving problems is that I don't necessarily focus too much on the NLP algorithm. Instead, I just try to really understand the problem, and that makes it a lot easier to pick the solution that's the most appropriate. So the best advice really that I can give you is don't worry too much about knowing every NLP algorithm out there. Don't worry too much about the newest tool out there. Instead, what I would do is just pick a problem that you think you can solve within a month or two that's reasonably nice in the sense that you can put it on a blog or on your portfolio or something like that, and just solve it. Like probably you're going to get a lot of experience from just solving a problem like that. And that'll be, in the end, I think, just a little bit more useful than understanding the latest and greatest in deep learning for machine learning processing. This is my personal experience, at least, but I would focus on pick a problem and try to solve that instead. That should be the starting point.
That's what I usually do. I just get started and get my hands dirty. But then a professor whom I know told me to go back a little bit and dig a bit deeper into the basics and
Are you still in university? Are you?
Actually, I graduated. I just graduated.
Okay. I mean, so the way I like the personal experience again, right? But I think if you're in university, that's also the time to make like theoretical investments in your life. Like when you're, when you have a job and a family and stuff, you have a little bit less time to properly read all of these mathematical books. But if you're in university and your professor is telling you invest in this now, I think that's still pretty good advice. The thing though is like, if I think about all the problems that I solved in university, and if I think about the problems that I solve now, in university, all the problems were like pretty clean. It's like you get a clean data set, you can do everything inside of a Jupyter notebook. And then looking back, it feels a little bit more like I'm solving an exercise than solving an actual problem, because actual problems at actual companies are messy. The data sets are super dirty. Like it's hard to get data in the first place. There's all these compromises that have been made. It's a different environment. I think the problems that you face in industry don't necessarily compare very well to what people do in academia. Now, again, it's also not my background, so I don't want to have too much of a judgment on it. But from my perspective, it doesn't necessarily seem a requirement to really go in depth into deep learning. That's the main thing that I have at least noticed. The most successful chatbots that I have heard of are designed by listening to users, not because someone in the team wrote the best algorithm. My experience so far, at least.
Well, yeah. The thing is, you know, when you graduate at the time of coronavirus and you have nothing to do, I think it's a good idea to fall back at it and dig deeper.
Sure, but let me put it this way. What do you think it's better to learn a new math trick or maybe a new Python library?
Well, depends on what you need.
Sure, exactly. So it's probably better to focus in on the problem. One thing you can do, though, is you can say, well, I want to learn this tool, so I'm going to look for a problem where I'm forced to learn the tool. That can be fine. Maybe a cloud provider, right? If you've never, let's say you want to analyze a data set that doesn't that's bigger than the memory on your laptop, you might need to do a trick with Spark or with some cloud provider. That can be super useful. But again, like the main thing I want to get across is don't feel obliged to focus on the deep learning or the coolest algorithm. Mainly because libraries like Rasa and Spacey, we try to make it easy for you, such that you don't need to be an expert on the algorithm. It's going to become a commodity. You also don't have to write your own linear regression anymore because scikit-learn has it.
Yeah, 2 lines of code, and that's like half a course.
I mean, like for logistic regression, let's say if in scikit-learn, right? Sure, it's 2 lines of code, that's fine. But if your data set's imbalanced, you can still do the class weight trick inside of scikit-learn, right? I would argue that even if you don't write your own logistic regression, it's more important to focus in on the problem, let's say one that's super imbalanced and you know how to deal with that, than that you write your own logistic regression. To me, that feels like a cool exercise, but a waste of time if I'm trying to solve a problem.
Yeah, I mean, unless you are trying to do fundamental research, it wouldn't really do you so much.
If you want to do fundamental research, by all means, go for it, right? I mean, there's people who want to become a PhD. That's perfectly fine. It's just that in my experience, the most progress is made by just thinking about the problem. I think one example that might be nice to share is, so if people are interested, I have this YouTube channel on behalf of Rasa. It's called the Algorithm Whiteboard. And basically what I try to do there is I just try to explain algorithms that our community members find confusing. So if you're interested in like transformers or BERT or some of that stuff, it's just me explaining like I have done today about all of these different algorithms. The episode that I'm currently working on is an episode that's about toxic language, which is a very, very hard problem. So in one of these episodes, what I'll be doing is I'll be using all sorts of pre-trained embeddings to see if I can detect this toxic language quite well. Now, the first problem in this data set, which you only unravel if you have a look at the data set yourself, is that it's very imbalanced. There are way more texts that are not toxic than texts that are toxic. So any classifier will be 90% accurate if they just say it's not toxic all the time. So that's the first issue you're going to have to try and tackle. The second issue is that whether or not something is toxic depends a lot on culture. When I was a teenager and I was on an online forum, I might say something like, "Oh man, that's totally badass." Which is not that's a compliment. That's not a bad thing to say, but it has the word bad and it has the word ass in it. So most algorithms are going to fail here. And this is just one example of how, like, if you do this toxic language detection wrong, I mean, you might block all the teenagers on your platform by accident, which is something you don't want to do. But obviously, this goes further than just teenagers. This also is like cultural and dialects and all sorts of these things. So, like, if you want to solve this problem quite quickly, I hope it's clear that you need more than grid search. You really have to dive deep into, okay, what are the things about this problem that make it interesting? And to me, at least, I've always found it to be way more rewarding to first understand the problem and then look for an algorithm, as opposed to the other way around. Personal experience, again, feel free to fill this in if this is meaningful for you or not, but I've always found this to be like a rather nice approach, especially if you're interested in learning.
Thank you, Vincent. From your experience, what would be the best chatbots that you tried that are built on Rasa and they are available publicly? I would say that maybe we can try some like customer sites.
So we've got a few. So I'm currently trying to make this virtual game, like this chatbot game. I wouldn't call it the most successful, but it's certainly the most fun to make. It's fully open sourced, and people are like welcome to contribute. I think that like if you go online, we've got a couple of like assistants for use cases. So if I recall correctly, financial bot is one. So we have this customer support team, and they have a couple of these demos. So we've got this one demo here that's let's pretend that you're a bank. What might a chatbot look like? And it's just this demo project that you can go ahead and start with. Like again, the whole point here is that this is meant as a starting point, but there's a couple of things in here like human handoff, like there's an assistant, but at some point we have to involve a human that's implemented in here. So I would look at some of these demo projects. By and large though, a lot of like the main, almost I think it's safe to say the main use case for these Rasa assistants is like customer service. So probably a lot of frequently asked questions, like that's a use case, but which frequently asked questions apply for you depends on your company. But that if you're looking for like an afternoon project with like your team, making a frequently asked questions bot for your own Slack channel might be like a fun little project to also get started with. Those are things that I recommend.
Thanks.
And if I may add, I think you can connect Rasa with WhatsApp and also Facebook Messenger. So this can be also fun to make. Yeah.
Like there's a couple of things still missing. Like probably next quarter, I'll be looking into making this work for Discord because that's getting popular too. But yeah, Slack works, WhatsApp works, text messages work. There's a bunch of services. You have to check the docs for more information. But we try to cover most things there.
Awesome. And I think you should jump on the Discord hype train with the rumors of their IPO. That would be a good idea.
And if nothing else, it's fun to make, right? I mean, it's always fun to make new tools and new connections and stuff. It's part of the cool job.
Sure. I guess we're almost at our time. Thank you very much, Vincent, for taking the time to tell us about Rasa, showing us this amazing example of word embeddings in Arabic, and showing us the library Human Learn. I know myself, I'm going to spend hours playing with that labeling.
So by the way, Human Learn, there's like a video tutorial on the website as well, in case you're interested. If there's any issues with it though, immediately let me know on GitHub, because I like to think that it will work for Arabic, but if it doesn't, I have to know as soon as possible.
Sure, definitely. And thank you all for joining us in this cool talk. Don't forget to check out our Twitter page at PyData Riyadh. And also, please provide your feedback on what Vincent showed us on either of the libraries he demonstrated this evening, either directly to Vincent on Twitter or GitHub, or on this Google form that we're going to share. And one last thing, I had to get over to Dania.
Thank you, Abdullah. Okay, so with this, we conclude our talks for the year 2020. And I just want to say thank you again, Vincent. I also want to say thank you, everyone. Without you, this wouldn't have been possible. So thank you for joining us. And we hope that the year 2021 will be first a much more safer year around the globe. And secondly, an exciting and interesting chapter in PyData Riyadh chapter, where we have workshop talks and sprints for everyone to enjoy and just make a very great community out of. So yeah, stay tuned, everyone, and see you soon.
Thanks for organizing.
Thank you.
Thank you, Vincent. Thank you, everyone.
Yes, sweet.